Welcome to the next tutorial on current electricity. Here we'll start solving the problems. First, the problem number 1. Two resistors with resistances 5 ohm and 10 ohm respectively are to be connected to a battery of EMF 6 volt so as to obtain 1. Minimum current flowing, 2. Maximum current flowing. Option A. How will you connect the resistances in each case? Calculate the strength of the total current in the circuit in each case. Okay, let us first of all find out what the problem is. First, draw the diagram, because drawing a diagram is most important. Okay. Here I have one 5 ohm and another 10 ohm resistance, and I need to combine them in two possible options. One is in series. When I connect in series, this is how it looks, and when I draw in parallel, this is how it looks. Okay. Now I need to find out in which connection the current flow is minimum and in which connection the current flow is maximum, and in each case I need to find out what is the amount of current that is flowing. Okay. Now when I am connecting in series 5 and 10 ohm, the net resistance is 5 plus 10, that is 15 ohm, and battery is having 6 volt. So in the case of series connection, the current flow will be potential difference upon resistance. Now resistance is in the series, it is 10 plus 5, that is 15 ohms. Therefore current flow is potential difference upon resistance. Potential difference is 6 upon 15, which is 0.4 ampere. So let us see what is the current flow in case of parallel. Now in the case of parallel, the net resistance or resultant resistance can be obtained using the formula 1 by R equal to 1 by 5 plus 1 by 10, which is coming as 3 by 10. Therefore R equal to 10 upon 3, which is 3.3 ohm. So in parallel connection, the net resistance is 3.3 ohm. Potential difference is the same, V is the same. Therefore current flow is 6 upon 6 by 3.3, which is coming close to 1 point something. Let us see how much it comes, which is coming to 1.8 ampere. So 0.4 ampere is the lesser than 1.8. So in case of series connection, we get the minimum current flowing. So this is minimum. And 1.8 is the maximum. Okay, so let us write the answer here. For minimum current flow, the resistances have to be connected in series. And for maximum current flow, they are to be connected in parallel. This is for the question A, and for B, where you have to calculate the strength of the current. Now the minimum current is, in the case of series, it is 0.4 ampere, and maximum current, which is in case of parallel, is 1.8 ampere. So this is the solution to the first problem. Now let us start working on the second one. The circuit diagram in figure 1.1 shows the combination of three resistors 4, 3 and 6 ohms. Find one total resistance of the circuit. It has three parts actually. First we need to find out the total resistance of the circuit. That means what is the total resistance out of combination of these three resistances. Now here you see, out of these three resistances, two are in parallel. So first we need to work out on the parallel resistance. When 3 and 6 ohms, they are connected in parallel, and then whatever is the net result coming from there has to be again calculated with the other resistance, that is 4 ohms. So now 3 ohm and 6 ohm are in parallel. So what is the net resistance from here? So net resistance due to this is 1 by R. We can do it from using this formula, 1 by R equal to 1 by 3 plus 1 by 6, which is 3 by 6, which is 1 by 2. Therefore net resistance is 2 ohms. Now let us see if we can simplify this diagram. So this becomes 2 ohms. So now effectively we have one 4 ohm and another 2 ohm in series, and the battery is 12 volt. So now we have one 4 ohm and another 2 ohm in series, and the battery is having 12 volt. Okay, then what is the net resistance from 4 ohm and 2 ohm, which is because they are in series, so it has to be 4 plus 2, that is 6 ohms. So net resistance R equal to 4 plus 2 equal to 6 ohms. So this is the answer to the first part of the problem. So this is the total resistance of the circuit. So let us write it here. So total resistance of the circuit is 6 ohms. Remaining part we will solve in the next tutorial.